Okay, these are just some examples from exercise 3.3, some uses of undetermined coefficients. Now, if a polynomial of the nth degree, if two polynomials of the nth degree are equal for more than n values of the variable, then they are identically equal. That is, they are equal for all values of the variable. Also, the coefficients of like powers of the expression are equal. This symbol here means identically equal, where you've got an equal sign with another line there. So it's used to indicate that two expressions are identically equal. Okay, now in the first example, it says to find the constants m and n such that x minus 26 over this denominator, x plus 2 times x minus 5, equals m over x plus 2 plus n over x minus 5. You can see that the denominator of this first fraction, this expression, the fraction here on the left-hand side, is just the lowest common denominator of the fractions on the right-hand side. So we will just start with the right-hand side, and we've got m over x plus 2 plus n over x minus 5 equals, if we go common denominator, we've got m times x minus 5 plus n times x plus 2 over x plus 2 times x minus 5. Now we're trying to get this expression here in a similar format to this. So let's just expand. So what we'll do, so therefore this expression, this was the right hand side, it's equal to x minus 26 over x plus 2 times x minus 5. Now instead of rewriting this out all the time with denominators, let's just say equating numerators. So equating numerators, and that way we don't have to write the denominator each time. We've got that m bracket x minus 5 plus n bracket x plus 2 is equal to x minus 26. Let's expand. Mx minus m, or 5m that is, plus nx plus 2n equals x minus 26. Let's put any terms with x's separate to those without x's. So we've got x as a common factor here, m plus n. Then we've got minus 5m plus 2n equals x minus 26. Sorry, I'm missing an x here. So we've got m, sorry, you can't see this very well. We've got m plus n in brackets times x, or I'll just put the x out the front actually. So x times m plus n in brackets minus 5m plus 2n equals x minus 26. So therefore we've got two equations that we set up. So therefore the coefficient of the x here is 1, so therefore m plus n equals 1. I'll call that equation 1. And minus 5m, equating constant terms without x's, minus 5m plus 2n is equal to negative 26. That's equation 2. Now we can do this a few ways. We can, so we're just solving simultaneous equations. You can do it any way you want. I'm going to just do equation 1 times 2 as opposed, equation 1 times 2. Sorry, you can't see that properly. So I'm just going to multiply equation 1 by 2 to make the coefficients of the n the same. So I've got 2m plus 2n equals 2. Okay, I'll call that equation 3. And then we'll just do equation, equation 3 minus equation 2. That way we'll get no negative. So equation 3 minus equation 2 gives us 2m take away negative 5m, which is 7m. And 2 take away negative 26 is 2 plus 26, which is 28. And so therefore m is 4. And therefore if m is 4 over here, we know that n will be negative 3. Okay? Now there is another way we can do this. Instead of expanding here and comparing like terms, there is another way we can do this from this step up here. What we can do, we can substitute certain values of x here. So we can substitute, so we can take this expression up here and we can say when x equals 5, the reason we'll choose x is 5 is that we'll lose this whole expression here with the m, and we'll substitute x is 5 here and x is 5 there, and we'll be able to evaluate what n is. So we can do it this way. So when x is 5, we get 0m, and we get 5 plus 2 is 7n equals 5 minus 26 is negative 21, so therefore n is negative 3. And we'll also, taking this here, we'll do another substitution to eliminate the n, and that would be when x is negative 2. And in substituting in here, we'd get negative 2 minus 5 is negative 7m equals, now negative 2 plus 2 is 0, so this becomes 0, and we get negative 2 minus 26, sorry, is negative 28, and so therefore m is 4. So now that is obviously a lot quicker than this method over here, okay? So what we're going to do is, where we can, we're going to use this method here, where we can. And this particular example here is a good example where you can do this, and it is a lot quicker method. Okay, now, exercise 3.3, question 8. We're going to try both methods again, the two methods that we used above. This time, first time, we're going to use that first method of substituting. So we've got here, find the constants a, b, and c such that y cubed plus 2y squared is equal to this expression over here. So something good to substitute would be y is 0. So we're going to substitute different values of y. If we substitute y is 0, we'll lose all of this because we get 0 times whatever these are, it doesn't matter. We'll get 0 here and we'll get 0 there, and we'll actually be able to work out what d is straight up by substituting y is 0. So let's start with that. So we're going to substitute y is 0, and we will get on our left-hand side that 0 plus 0 equals, here we've got 0 plus 0 plus 0 plus d. You don't have to write them all out. You can just write that d is 0 with that, okay? Something else that we can try and substitute. If we substitute, for example, here y is 1, then we'll lose this expression here. We'll lose this expression here for y is 1. We will get just a c there, and we already know that d is 0. So let's just do that. Substitute y is 1. So on the left-hand side, we'll get 1 cubed plus 2 times 1 squared is just 1 cubed plus 2 times 1 squared. It's 3. And on the right-hand side, we'd get 0 plus c. And we know that d is 0. So substitute y is 1, and of course d is 0. And we get that. And therefore we get that c is 1 plus 2 is 3. So we've already worked out what d and c are. So in our subsequent substitutions into this, we can substitute what c and d are. We're just looking for, oh, it didn't say to find d anyway, but I think it should have. Now we just need to find b and a. Now let's see, another value of y that we could substitute would be y is 2, okay? Because you'd still have, you'd wipe out the a, but you'd still be able to work out b, and we know c and d. So we're going to substitute y is 2, and of course c is 3 and d is 0. So y is 2 will give us 8 plus 8 is equal to, this will be 0 here, plus if I do y is 2 here, I get 2b times 1 is just 2b. We know that c is 3, so we get 3 times 2 is 6. And we know that d is 0. So here we've got that 16 is equal to 2b plus 6. In other words, 2b is 10 or b is 5. So, just having a look, we just now need to work out what a is. Now, if we look here, we get our y cubed term by multiplying this ay by the y and by this y. So by inspection, we know that y cubed is equal to ay times y, because it's the multiplication of these three things that I'm pointing out here that gives you your y cubed term. So therefore, a must equal 1, okay? And also, because you've got a monic polynomial here, this is a monic polynomial, therefore a will be 1. Now that's one method. The other method is to just expand the right-hand side and to equate coefficients, okay? So let's try that. So, or our second method is we've got y cubed plus 2y squared is equivalent to or identical to ay. I'm going to expand this straight up, and I'm going to get y squared minus 2y minus 1y, which is minus 3y, plus 2, plus, may as well expand this as well, by squared minus by plus cy plus d. And just expanding this again, we've got ay cubed minus 3ay squared plus 2ay plus 6y squared minus by plus cy plus d. Now we'll need to put all of the y cubed terms together, the y squared terms together. We'll keep the y terms together and we'll keep the constant term on its own. So that's equivalent to ay cubed plus y squared. Let's see what we've got. I'll do the positive one, 6 minus 3a. Sorry, that's a b. Sorry, that's not a 6. That's a b. Got to be careful there. That's a b minus 3a. And the y term, we've got c minus b, or we can do the 2a first. So 2a minus b plus c, and the constant term on its own is plus d. Okay, now we can equate coefficients. So equating coefficients. We can see that there is no constant term here, so we already know that d is 0. We also know that that ay cubed is equal to y cubed, and so therefore a is 1, just what we did before. We also know that now we've got two equations that we need to look at. Equating the y squared, coefficients of y squared, we've got that b minus 3a equals 2, which means that that's the first equation. But we also know that a is, sorry, I might just get rid of that, but we can substitute a is 1, so therefore b minus 3 times 1 is 2, and so therefore b is 5. So if we know that b is 5, and we know that a is 1, we can look over here. We know that 2a minus b plus c we know equals 0 because there's no y term. And we'll substitute what a is, so that's 2 minus 5 plus c equals 0. And so therefore c would be 3. Okay, so that's the other way of doing it. Okay, so there are two different methods that you can use. Question is also from exercise 3.3. It's question 16, and it says to express 4x to the power of 4 minus 12x cubed minus 40x squared minus 14x minus 1 in this form here. Ax squared plus bx, all of that squared, minus cx plus d squared, hence solve this equation here. Now, it'll be really hard to go from that to this, so what we're going to do is just expand this side over here. So let's take this right hand side, and we've got ax squared plus bx all squared minus cx plus d all squared. And expanding that, we've got this is of the format a plus b all squared, it's a perfect square. So we'd get a squared x to the power of 4 plus 2ab x cubed plus b squared x squared minus, and in brackets we've got here c squared x squared plus 2cdx plus d squared. Now opening those brackets, we've got, and I'm going to remove the bracket and also collect like terms at the same time. So the x to the power of 4 terms, there's only one, so a2 x to the power of 4, plus the x cubed term, there's only one, so we've got 2abx cubed. Now plus x squared terms, we've got b squared, and here we've got minus c squared. And for the x term, we've got minus 2cdx, and for the constant term, we've got minus d squared. So now equating coefficients of like powers. So equating coefficients of like powers, or of like terms, whatever. Okay, of like terms, either. We've got that. So comparing that with this, we've got that a squared is equal to 4. Now that gives us two solutions, that a is plus or minus 2. Looking at the x cubed term, we know that 2ab is equal to negative 12. Dividing by 2, we get that AB is negative 6. But we have two values of A here to consider. So when A equals 2, B is negative 3. And when A is negative 2, B is positive 3. Okay, now let's look at our x squared term. We've got that b squared minus c squared will equal negative 40x squared. So we've got b squared minus c squared equals negative 40. Sorry, negative 40, not negative 40x squared. We know that whether b is positive or negative 3, b squared is just 9. So we've got 9 minus c squared is negative 40, which means that c squared is 49. And so therefore we get that c is equal to plus or minus 7. Okay. Now we've got the x term here, so we've got that minus, with the x term we've got that minus 2cd equals x, but we've got this d squared term which we'll do first, the constant. Okay, so we've got that d squared is equal to 1. Because notice it's minus 1 and minus d squared, so the actual d squared is equal to 1, and so therefore d equals plus or minus, sorry, this is a 1. So d is plus or minus 1. Now, looking at the x term, we know that minus 2cd equals negative 14. So it's obvious that when, actually I probably didn't need to do this because we could have just gone here. When c is positive 7, we get that d would be the negative 1, and when c is negative 7 from up here, d is positive 1. Okay, sorry, when it's negative 7, negative, I need another negative, it would be negative 1. So I better have a look at this again. When c is positive 7, we get negative 14, so we just multiply by positive 1. So sorry about that. So when c is negative 7, d is negative 1. And when c is positive 7, d is positive 1. So let's look at our solutions. So therefore the solutions are, or the solution is, a is 2. Now we know when a is 2, b is negative 3. Then we'll have c equals plus or minus 7, because we've got to take each one of those. And when c is plus 7, d is plus 1, and so d is plus or minus 1. Okay, our other solution is a is negative 2, b is positive 3, c again will be plus or minus 7, and d will be plus or minus 1. Okay, so they're the solutions to that. So these are just the solutions to A, B, C, and D. We're actually going to have to turn over the page. So actually what we might do, we might take this question. We'll rewrite that one over the next page. What we'll do, we'll just continue. So we'll continue down here. Down here. Okay. So we'll keep going. All right. So it says to express that in that form. So we'll continue with that. Okay, so I've got 4x to the power of 4, just write it down here. 4x to the power of 4 minus 12x cubed minus 40x squared minus 14x minus 1 is equal to, now we know that a is plus or minus 2. I'll do the plus 2 one first. So I've got 2x squared. Now when a is plus 2, b is minus 3, so minus 3x all squared. Minus, now we know c is plus or minus 7. I'll just do the plus 1, so 7x plus 1, because when c is 7, d is positive 1, so that's squared. Okay, now what I'm going to do here is expand. We're trying to express this in this form, which we've done. Hence, to solve this, we will just, to solve this equation equal to 0, we'll put this now equal to 0 and solve. So now we've got 2x squared minus 3x all squared minus 7x plus 1 squared equals 0. Now we're solving this. We'll expand. And we've got 4. Now, we've got two options here. If we expand this with perfect square, and this as well, and combine, we're just going to probably get that. Okay, so the other thing we can see here that we've got is that so I wouldn't be doing that, I wouldn't be expanding it again, you're probably just going to get this, okay? So what we need to do is think of another method. Now we've actually got a difference of two squares here, so a squared minus b squared. So let's do a plus b times a minus b equals 0. Alright, so I'll just keep going here. So I've got 2x squared plus 4x plus 1. And here I've got 2x squared minus 10x, take away 1, equals 0. Now we need to solve both of these. So if you try crisscross, I don't think you're going to get a solution. Okay, factors of 1, it's not going to work. You need 3x in the middle, and we don't have that. I believe similarly with this, yeah, there's no way we're going to get a minus 10x. So what we're going to have to do is use the quadratic formula. So x is negative 4 plus or minus the square root of 16 minus 4 times 2 times 1 over 2 times 2. And for this one, we've got x is positive 10 plus or minus the square root of 100 minus 4 times 2 times negative 1 over 2 times 2, and so we've got negative 4 plus or minus the square root of 8, which is 2 root 2, over 4, and here we've got x is 10 plus or minus the square root of, this is the square root of 108 over 4. Now, dividing everything here by 2, we get negative 2 plus or minus root 2 on 2. And here we've got 10 plus or minus, now 108 is divisible by 3 because 1 plus 0 plus 8 is 9. Sorry, just running out of room there. So 3 into that, it's 36, okay? So 36 times 3 is 108, so therefore we've got plus 6 root 3 over 4. And these are all even, so the 10, the 6 and the 4, so dividing through by 2, 5 plus or minus 3 root 3 on 2. And so therefore our solutions are those, negative 2 plus or minus root 2 on 2 and 5 plus or minus 3 root 3 on 2. Now if we put, swap them around and do the exact, so if we put here, what we did was A was 2 and B was negative 3, C was 7 and D is positive 1. If we did A is negative 2, B is 3, C is negative 7 and D is negative 1, and expanded and took everything over to the other side, we would end up with more than likely the same solution. So I think we would. I mean, you can try it if you want. Look, I'll just, so the solutions are those two. I can quickly try it here. So if we've got negative 2x squared plus 3x squared minus negative 7x minus 1 squared. So this would be the situation where we've got all those opposites, okay? Let's see what we get. Doing difference of two squares, we've got negative 2x squared plus 3x minus 7x minus 1 times negative 2x squared plus 3x. It would be, so this was a plus b, and to do a minus b, I'd have plus 7x plus 1 equals 0. So I'd get negative 2x squared minus 4x minus 1 times negative 2x squared plus 10x plus 1. Now, if you compare this with that, it's the exact opposite. Where there are positives, here there are negatives. That's a positive, that's a negative. These are both negatives, they're both positives. So you do not need to therefore do that other solution, okay? Because you would get exactly these answers, okay? If you, for example, took everything, once you solve each of these, you would get exactly the same as those. and I'll show you just with this first one, you get x is positive 4 plus or minus the square root of b squared 16 minus, so you've got 16 minus 4 times negative 2 times negative 1 becomes 16 minus 8, which is root 8 again, over 2 times a, which is 2 times negative 2. So you've got the negative 4, you've got 4 plus or minus, again, 2 root 2 on negative 4. And if you divide everything by 2, or you would get 2 plus or minus 2 root 2 on negative 2, which is also the same as negative 2 plus or minus 2 root 2 on 2. So you get exactly the same solutions, so you don't need to do it for the different A's and B's, okay, and C's and D's. Now what I'm going to do, I'm just going to rewrite this question, factorise this polynomial, and find the polynomial q of x and the constants a, b, such that such that px is equal to x squared times q of x plus ax plus b. I'm going to write that on the next page, okay? Okay, now to factorise that polynomial. So we've got x to the power of 4 plus 2x cubed minus x squared minus 2x. Now we notice that x, you can factorise in pairs if you want. The other thing you can do is take out x because it's a common factor. So there are, two ways you can do it. Look, I'll start by taking out x because it's a common factor. So we get x times x cubed plus 2x squared minus x minus 2. Then we could see if we could factorise in pairs. And I think we can. So we've got x bracket x squared times x plus 2. See if we can do another x plus 2. I'll just put square brackets here. And we'd put negative 1 here. So we can do that. So we've got x times x squared minus 1 and times x plus 2 squared. And we know that x squared minus 1 is a difference of 2 squares, so that's x times x minus 1, x plus 1 times x plus 2. Sorry, it's not x plus 2 squared, it's just times x plus 2. Sorry, it's just a bit late at night and I'm a bit tired, so we've got x squared minus 1 times x plus 2. And factorising that, okay, we can see we've got x to the power of 4 there as well. Okay, now, given that your polynomial in x is equal to x squared plus 1 times some polynomial q in x plus ax plus b, we've got to find those constants a and b. Now, that is the same polynomial. Now, given that this polynomial is that, for the polynomial to have degree 4, then, so if the polynomial is to have degree 4, then q of x has to have degree 2. So then q of x must have degree 2. So we're going to just let q of x equal to, because x squared times x squared will give me an x to the power of 4. So let's just let q of x equal to, now we can't use a, b, c and all that. We'll just use k, so we've got kx squared plus mx plus, we don't have any c's here, so I can throw in a c, okay, where k, m and c are real numbers. So therefore, what we've got is x to the power of 4 plus 2x cubed minus x squared minus 2x will be equal to this, which is x squared plus 1 times kx squared plus mx plus c plus ax plus b. So what we'll do now, we'll just expand that, and so you have to assume that there may be an x term here and a constant term. We can't just put kx squared, all right? Because if it's a quadratic, it can have an x term and a constant term, all right? So let's just expand here. We've got kx to the power of 4 plus, I'll just multiply through by x squared first, plus mx cubed plus cx squared plus kx squared plus mx plus c plus ax plus b. And now collecting like terms, we've got kx squared plus, there's only one cubed term, plus mx cubed plus, there are a few x squared terms, so we've got c plus k. And the x terms, there are m plus a, plus constant terms, we've got b and we've got c. So these are our constant terms, b and c. Now we can equate coefficients of like terms, okay? So equating coefficients. We've got that kx to the power of 4 is x to the power of 4, so therefore k is 1. Okay, we've got that mx cubed equals 2x cubed, so therefore m is 2. Or we can just write k is 1, m is 2, just straight off. We know that c plus k is the coefficient of the x squared term. So c plus k is negative 1. We know that k is 1. So c plus 1 is negative 1. And so therefore c is negative 2. Okay, we know that coefficient of the x, m plus a, is negative 2. So m plus a is negative 2. We know that m is 2. So 2 plus a is negative 2. So a is negative 4. Looking at the constant term, we know that b plus c, well, there is no constant term there. So b plus c is 0. We know that c is negative 2. So b minus 2 is 0. So therefore b is 2. So therefore, we have found the constants a and b. Okay? So therefore, a is negative 4 and b is 2. And so therefore, q of x is we'll just look at q of x and we'll just look at what ax plus b is, and we'll just rewrite that polynomial again. So q of x we know was kx squared plus mx plus c. There it is. Okay. So kx squared, k is 1, so it's just x squared plus m. M is 2, so plus 2x plus or minus 2. And ax plus b is negative 4x plus 2. And so therefore your polynomial in x can be written as x squared plus 1, x squared plus 2x minus 2, minus 4x plus 2, if we were to write it in that form up here. So if we were to write it in this form, it would be this. Polynomial in x is that. Okay? And that's the end of the examples for exercise 3.3 question 18. And I'll just let you know which questions to do when I send you an email.